Hello, how are you guys doing? So thanks a lot for coming to a presentation during lunch. That shows how much you guys are interested in security. And actually, the name is a bit different. I think this is a cooler name than the one we actually showcase. And it will make a lot of sense during the presentation. But right before that, I would like to start with a couple introductions. So first of all, who am I, right? I have more than 15 years in software engineering experience, mostly back-end software engineering, right? And I joined Nubank close to 5 years ago as a back-end software engineer. And then I started to see a bunch of different bad things all around the infrastructure. And we were a 13-engineer team at the time. And it was just not possible to have everyone working on security. So I talked to our CTO and started working in actually patching things and closing gaps. All of then I became a security engineer and started studying a lot of that. After more than a year doing this, I actually switched track to management side. I became the CISO for our Nubank and built a team close to 60-person team, working mostly in security. And recently, close to 6 months ago, I switched back to the technical track as a principal engineer and security evangelist. So part of my job is actually telling people about the really good things we do about security at Nubank right now. And Nubank is a $10 billion fintech company from Brazil. We are expanding internationally. We started in Brazil. We have closer to 7 million customers. That is actually a no number. It is a bit higher now. And we are a 6-year company, more or less. So I was there since the early stages of the company. We have a great NPS, and we started with a credit card product there. And then after a while, we launched a savings account. Actually, not really a savings account. It's just a checking account or a mix of both. And then a rewards program for our credit card. We now have personal loans and a bit of other stuff we are working, such as accounts for SME and things like that. And we are expanding internationally. So we are launching in Mexico, maybe in near future in Argentina. And our main focus is actually Latin America. And then the next introduction I want to make is actually about what is an attacker. Right, so have you guys heard of Rio in Brazil? We had the Olympic Games there a couple of years ago. And there was this really interesting piece that was circulated from Brazilian intelligence group about be worried about people with computers and hoodies and things like that because they may be hackers, right? And this is actually one of the first pictures you get if you Google for hackers. And yeah, so hackers are hooded guys with laptops. So half of this conference is comprised of hackers. And actually, oh, sorry. Okay, oh, that's better. And actually, an attacker is a bot. Usually, really, I won't say that here, but a bot that doesn't really care about us and just do whatever. And most of the times, especially in the financial industry, you're not dealing with a single bot. You're dealing with hundreds of bots crawling and trying to figure out ways to attack you every single day, right? So that is quite important. Don't think of hooded guys. You are thinking about an army of bots that want to trample over your customers. And the main thing, who here actually works in security? Right. Software engineers, managers overall. OK. So the way we see security is substantially different than, than a lot of people in the industry, right? So we don't think we are protecting a company. That's not what we are doing there. We are also not protecting data. That is not our main driver. We are actually protecting our customers. Our customers, our employees, and then our company. And in this specific order, because if you focus on protecting data or protecting your company, your customer is going to suffer. So we first protect our customers, then we protect our employees, and consequently, we are protecting the company and the value that is added for that. And this is actually quite important because, for example, since we are not protecting all those things, this changes substantially what we do. So we had this thing that happened once that we had a customer, and the customer was trying to buy an engagement ring for his girlfriend at the time. And he called us and said, hey, I need 100-something reais limit increase. That's close to $20 limit increase, so I can buy the engagement ring. Our customer support picked up the call, was able to grant the limit increase. He bought the ring, proposed it to his girlfriend. She accepted, and then he came back to share that with us. And the thing that was really touching about the master is that the way he saw it was that Nubank actually was part of the most important moment of his life, right? And where did I talk about security in the story? Every single step. So, and that is one of the things we take really into account in regard to security at Nubank. Security must be invisible. No one should see security there. And we are protecting this value. So when the customer support person went there and actually granted the limit, there are a bunch of different controls around that allows for this to happen. The customer got in touch with us, and we knew it was the customer. We actually verified it was the customer. So there is security all around everything, but not in the middle of the work. So people, we try, we fail sometimes, but we always try to not make work harder. And actually, we try to make it simpler and easier. And AWS helps us a lot in this, right? AWS fights for us. So there are services such as GuardDuty that finds really strange things happening in the infrastructure. Once GuardDuty showed us that we had a server that was completely open to the internet on our staging environment. So it was pretty good that we just closed the security groups, and that was it. In other cases, we had a bit of false positives with GuardDuty. It was showing that we were having random DNS resolutions all across the infrastructure, which is usually a signal of DNS exfiltration and things like that. And that was a false positive. We were able to verify. But in the process, we also learned that our infrastructure didn't have enough visibility around DNS and not enough controls around DNS. So we actually implemented better controls and better visibility all around DNS. So pretty good up to now in this 1 or 2 years we have been using it. It has AWS Shield. So we don't need to worry about DDoS happening. And especially in the financial industry and retail market, DDoS are the bane of our existence, right? There is always something happen. And one thing that was pretty cool that happened once with AWS Shield is that we got intelligence information that most of the companies in Brazil, the Brazil financial sector, were getting DDoS. And our name was actually in those companies, and we didn't see anything happening. The whole industry was like intermittent service connections and things like that, and we were like, well, everything's working here, so pretty good. And then they have the Shield Advanced that actually brings a lot of peace of mind. Twice we had some kind of, probably a residual DDoS hitting our staging services here in the US. And we just opened a ticket that was quickly escalated for the DDoS team. In 2 hours, everything was clear, and we didn't spend, I don't know, a week fighting on DDoS there. Also, physical security, right? This one usually doesn't get much mention, but whoever actually saw an AWS data center or something like that? We didn't, right? They have a, oh, you did?
No, so
Oh.
I live in Nashville, out in Virginia, so AWS has a lot of data centers.
Yeah, exactly. But usually we don't go into a data center. Exactly, yeah. Yeah. Oh, yeah, that's pretty cool. It's in front of our, I'll try that someday. But then we don't see a data center. There is the physical structure. They have a lot of papers published on how they secure things with software layers and physical layers and a lot of security there that we don't need to build. And this is quite interesting because I had once, we have a couple physical data centers because those are required by either regulation or the partner we are using in that. And I went to one data center. We don't use that anymore, thankfully. And when we were closing the contract, it was pretty hard to actually get into the building. They were verifying everything. They had us scanning the hands and going one person at a time through the check-in door. Oh, that was pretty good. I went back there 3 months later because one of our HSM had fried. So I was there to actually exchange the HSM. And well, it was like, the guy just opened the door on the side for me. Oh, come here with your HSM. I got into the data center, went to do the maintenance, switched the HSM, bring it back, and then like not even checking out, right? I was just, hey, can you open the door for me? And I was like, sure. Open the door, I was out with an HSM. That was one of the reasons we stopped using that data center. So these kind of things happen, eventually you learn. So, and we don't need to worry about that with AWS. So we are safe, right? We are completely safe if we use AWS. Nothing bad can happen to us. Yeah, that's not really what happens, right? There is the shared responsibility principle. The main idea behind it is that AWS will do what they can to protect their infrastructure and mostly up to network layer. That's what's possible. In other services, they can provide a bit different coverage there. But we need to do our part also. So security groups, right? You're probably using really fine controls around security groups, so only opening necessary ports and not doing crazy things like allow all traffic from the whole road to any part in the infrastructure, right? And you are verifying your, I don't know, 10,000 security groups if they are all matching the restrictions you guys have, right? You probably also have a SOC, right? So you have the alarm that gets triggered, and someone will go there and say, oh, this is not an issue, this is not an issue, this is not an issue, and that will keep on going forward. A lot of process. The financial industry loves process. So everything has a process for that. And sometimes it can take 6 months for you to actually write some code and that arrive in their production environment. So they do love process for some reason. And volumetric controls, right? So, you can only attempt to log in 3 times, and if that fails, you need to go to a branch to actually unblock your account, and the experience is pretty bad when that happens. And usually, volumetric controls is something that we add when we have a worse failure at the protocol level, right? We cannot verify anything there, so we try to minimize the exposure we have. And the main thing is that those tools used to work when we had, I don't know, people attacking services. And that has stopped for a while. And the main thing is that we're not fighting a fair fight. And we're fighting against bots. So timing matters a lot. I tend to say that this is actually a time fight. We are trying to buy time while the attackers are actually trying to improve their tooling and attacking us faster and faster and in different ways. And there is a complete asymmetry here that the attacker can invest as much time as they want into preparing an attack. And if they succeed once, that's good. And on the other hand, we cannot fail at any point, because if we fail, our customers suffer, the company can go down, and that's it. So, and well, attackers are humans, right? So sometimes they stop, sometimes they don't. Sometimes they spend 2 years trying to break into a company. And just to show what I mean when I say this is a time fight. So I'm a former manager coming back to the principal track, to the technical track. So I'm kind of rusty. So if I get to a server, what I can do in 10 minutes? Nothing. Nothing. With no preparation, just got to the server, nothing. But I'm not one of the best at this, right? If I have a couple hours of preparation and I got lucky and the server was actually a bill payment service or something like that, I can probably buy beer on the bank's account and that's it, and have a bunch of beer for everyone that is here. So people don't need to actually come to reInvent to have drinks with the Expo guys. We can just have beer for everyone. If I have a year of preparation, I can probably wreak havoc all across the financial industry, just moving money, creating chaos inside companies, and no one knowing what's happening, and that can eventually hurt the economy if you take into account how big a bank can actually, like, especially in Brazil, where banking is quite concentrated. So that's why we don't want to bring humans to a bot fight, right? And we need to create our own bots, because bots are faster. So no human SOC can actually respond to incidents as fast as a bot can respond. Bots are way more precise. If you have a whole flow of what you need to do and you need some person to actually perform every single action, they are going to forget actions. They are going to do something wrong in the middle. Bots, they are perfect for this. They just do action upon action upon action, and that's it. They won't make a single mistake all across the board, unless you program it then to do mistakes, which sometimes happen. But bots are really dumb. You cannot expect your bots to be autonomous and figure out things they need to do. You actually need to do everything there. So our main strategy is to actually unify what we have. So we have humans creating bots, and bots doing the whole work there. And how do we actually do that? Service that we probably mostly use for security is not a service designed intentionally for security. This is the Lambda services. We quite like doing this in Lambdas because we can have really granular permissions, right? So instead of having a lot of permissions for the service, the bot has only permissions to perform the action the bot actually needs to do. And we have many of these really small bots with really fine-grained permissions actually doing everything. We don't want to have, for example, a service for automated response, because if that service gets compromised, now the attacker can do a lot of stuff all across the infrastructure, especially destructive actions, because usually those bots are destroying some resource that was compromised or something like that. So these are really high damage permissions that usually they hold. And it is pretty easy to trigger from all across the board. And so we want to have all our tooling being able to actually trigger those bots. We want to have people triggering those bots. So anytime there is something strange, the first thing you do is just push the button, make everything stop, and then we start analyzing and understand what's happening there, right? So commanding your bots. As I said, bots are quite dumb. So we actually need to command them and make them do everything. So you need to log everything that happens. Everything that happens. If there is no log, you cannot understand what happened. You cannot protect yourself, right? And when I say log everything, I really mean log everything. So take your AWS config, fetch your guard duty logs, fetch ELB logs, another call really common. And really, really, really log everything, right? So fetch CloudTrail, enable CloudTrail for all your accounts for everything. Fetch VPC flow logs. Usually people just keep these logs for forensic analysis later. We don't like to do that much, especially doing forensic. Usually something bad happened, right? DNS resolution, Redshift queries. And even though they were designed for compliance, they actually show a lot of our infrastructure, a lot of information about infrastructure and what's happening there. So the way we see it at Nubank is that we are actually always doing forensic analysis, but as close to real time as possible, right? So we design controls around, oh, if this attack happens, this will be the pattern, and we look for the pattern in the terabytes of data that we process every single day. And you don't need to have this, but it helps a lot having a centralized place with all of your logs. So send everything to your CM tool. We don't use S3 and Athena for this, or even CloudWatch logs, because it was easier for us to set up and integrate with the rest of our infrastructure. But it should work. So it doesn't matter which tool you're using, as long as you can query there and trigger HTTP requests from that, you can actually implement this. And one thing that is quite important to think is this actually happening. So I'll work through a couple cases of what we have been doing with this at Nubank. So imagine the following situation. You have those pesky engineers messing with your firewall, right? They are just that, and they don't care. They open all the ports, and that's it because, oh, it's hard. So first of all, I'm also an engineer. So yeah, they are actually awesome engineer. Oh, it didn't strike through. Yeah, forget the pesky written there. They're actually awesome engineers trying to do their work, trying to figure out how to produce better products for the customers. So they're not, but they are still messing with the firewall, right? So we need to fix that. So we fetch AWS config. We actually have one specific rule that whenever there is something that changes on AWS, it will trigger this rule. And what this rule does is send the logs to the CM. So we have an integrated infrastructure there. After we fetch the AWS logs, we send that to CM. Then we just destroy the rule that was added, because that should be there, shouldn't be there. Like if you open SSH to the rest of the world, that's usually not a good thing. And then we go talk to the engineer that did that and politely educate him. And this is also important. We actually fixed the control that prompted the engineer to open the door, even though that was not needed to do. Another case, we have a machine querying a random DNS. That's the case I mentioned earlier about having some kind of exfiltration and things like that. So we fetch logs from Route 53. It has a bunch of DNS resolution logs there. Again, send to your CM. Again, shut it down. Remove whatever is doing that. If it is a machine, just isolate it from the network and notify your team to actually perform forensic analysis on the machine and figure out what's happening there. And sometimes it will be a lib that you just added to your infrastructure that was compromised on like a supply chain attack. And now it is distributing malware to your infrastructure. And those things eventually pass, and that happens. Another case, you're there and you have a really cool office with a fridge there, right? And, well, you're cool, so you have a smart fridge that can actually get compromised. And you see that it is trying to download your backups. And the main thing is that the only reason you can see that happening is because you actually have monitoring of your local network where your fridge is connected also. And hopefully you're doing really, granting really small permissions for people, or for your fridge, for example, right? But the flow is the same, right? Fetch information from CloudTrail. And then you can query for access denied or something like that. Just look for something that can show you the attack is happening. And then you should know you don't shoot a fridge. It has beer inside. You want to drink that after you solve the incident, right? You don't shoot that. You just revoke the credentials that were used there. And then probably something you need to do is about phishing training. Someone was there and set up the password as a Cinderella 123. This is actually a real used password that we find sometimes. Not used anymore, so way better situation. But yeah, probably teaching more about phishing, how that can happen, and how compromises happen in your infrastructure is pretty good. And one thing that is quite important here. So this was a failure, right? Having a Cinderella 123 probably violates every single information security policy that exists. Agree? It doesn't matter because the information security policy is actually a piece of paper. So a piece of paper cannot actually prevent people from doing this. If your controls fail, eventually you're going to find this kind of stuff happening on our infrastructure. It could be Cinderella 123 with an exclamation mark at the end, and well, that would pass most of the checks in most of the places. So you actually need to teach your workers how to better protect your infrastructure. Next one, and this actually happens from time to time. We find customers trying to fetch data from other customers, which is pretty odd, right? So one of the things that quite help here is that we don't use sequential IDs for anything at all. So usually we are going to see these as 404s happening on the infrastructure. But if you use sequence IDs, most of the recent compromises of services and not just downloading huge amounts of data from backup and things like that in Brazil happened because people were like, oh, let me see who's account number one here. Oh, that's the CTO of the company or the CEO of the company. And then from there, they try to do something else, right? So again, so we need to fetch logs, right? So we go to AWS, and there is no AWS log for that because that is on your application. So fetch your API invocation logs there. You can query that for subject mismatch with the resource being accessed. Again, you don't shoot a customer, never, never, that's quite important. So you block the customer. And when you actually get in touch, be really nice because it can be a fraudster. It can be someone that had their account took over. It can also be a security researcher that would submit a really good report for you and he found a vulnerability instead of the bad guys finding. So that can be a pretty good experience for them. And this one is a bit more serious here. So you look at your VPC flow logs and you have 100 gigabytes going to, you name which country you would like to have there. So, well, hopefully you have an agreement with that company to process your data and it is not just gigabytes of data just leaking, right? Again, fetch VPC flow, send to your CM2. In this case, you shut it down. Definitely, just kill the machine, and then you try to figure out what's happening there. And probably engage in incident response protocol, because if you don't have an agreement, that is pretty bad. But the thing is, you had 100 gigabytes going out, you detect that, you contain the attack. If 100 went through, you're probably going to lose a terabyte of data or way more. So this actually reduces your exposure substantially there. And we have been talking about building a lot of bots and having a lot of bots all across the board. And should we trust those bots? And if Terminator told us anything that we should, is that we should never trust Skynet. We should never trust bots. They're dumb. They will do dumb stuff. So we don't trust our bots, actually. We actually inject fake incidents there to monitor and have and know that our bots are actually working. And honestly, bots don't really care about that. They like repeating stuff. So let them repeat as much as they want. Your finance team may actually be a bit more worried about that. So be mindful of your finance team, right? And the really interesting part is that you can actually take this, if you just issue a report, it can be a log line or something like that showing that you did that. What you're doing is continuously testing your infrastructure. Auditors really love that. So you give them a report on this that you're testing, I don't know, every 5 minutes, every single day, all the time. They will be really happy with you. And you can call that an autonomous incident response infrastructure, and this sounds pretty cool for a lot of people. And another thing that we try to do most of the times and are always improve is this idea of not trusting and actually ensuring that something happens across our infrastructure. This is not our main line of defense, right? Everything I talked here is not what we actually rely on. This is the line of defense we have to catch things after something else broke. So this is the idea of defense in depth, right? You have your defense lines, and then after your defense lines, you have other defense lines looking for things and looking for failures on the previous lines, so you can actually spot those and fix. And this fits into this idea of a time fry, right? So if you have multiple defense lines, you're actually buying time against that attacker. And if the attacker is actually going through your security lines, you have more time now to react and figure out what's happening there. And the last part is, are we actually doing this? Because it is a lot of work to do this. And the answer is actually not for everything, right? Not every single case we should do automated response. There are things that just we don't care, such as something connecting to our infrastructure being completely declined by firewall rules or something like that. So these are actually part of our maturity model around our controls. And our maturity model is kind of First, there is nothing. There is no logs. We have no visibility on what's happening there. Then we work on visibility. So we have logs. Then we organize this information, so in terms of a dashboard or a report, so we can have a better understanding of how that actually influences our infrastructure, create alerts, and then we get to automate autonomous reaction. And we do have a really interesting case where we did this in this specific order. Because, for example, probably most of you actually have a login system or something like that. And as every single company that runs a login system, people try to abuse that and verify and have accounts. There are specialists into this, the account farmers. And the main thing, well, we are attacked a lot by account farmers. And we do have strong controls there, but the volume of the attacks and the percentage of possible compromises of accounts was increasing. And the thing is, people use bad passwords. It doesn't matter. Even if they use really strong ones, they reuse across different sites, so you have a breach on a big company, and that's it. Their password is compromised. They are going to compromise and take over accounts, especially in the financial industry. So what we did, we improved the logs we had there. We improved also the first control, but invested a lot in detecting when an account was compromised, because we were looking at patterns of what was happening across those accounts, and we have a really clear pattern from our application, our mobile applications. And if someone is doing automation against infrastructure, the pattern is substantially different. So we detect this pattern, we trigger an automated response that will block the account, reset the password, notify the customer, and then everything is okay. And we just monitor if this is working and how much this is happening across the board. So we know if we're getting a huge inflow, maybe giving a new compromise on a different service, or if things are okay for our customers. And that's it. Thank you all for coming to this lunchtime presentation. Yeah, I'll be around for questions. I think we have a couple minutes yet, so.